Today we're going to talk about another transformation, dilations. So when you go to the eye doctor and you have your eyes checked, sometimes they will use something to dilate one or both of your pupils. So basically, if you look at the picture on the left to the picture on the right, what will happen is your eyes dilate, means that it gets bigger. So it kind of like zooms in and then zooms back out, right? So the black in the middle of the pupil enlarges when you have your eyes dilated. So a dilation is one of the transformations that we are going to talk about, in which a figure is bigger or smaller. Now, when we talk about bigger and smaller with the words of dilation, we will refer to bigger for enlarge and smaller as reduce. And this will happen in respect to a point called the center of dilation. So you'll see in the picture here that we have two shapes. The red shape is this quadrilateral, and it has gotten enlarged from here to the blue shape, and this is the center of dilation, which is a point off to the side, which will be our point of origin. It's not always going to be that. That's what we're going to focus on this year. So then we want to look at identifying a dilation. So tell whether the blue figure is a dilation of the red. So the thing about dilations, which is different than the other transformations that we've been talking about, is that the dilation is definitely going to be bigger than the original shape or smaller than the original shape. The difference is when we did the rotations, the reflections, and the translations, remember the shape didn't change in size in any way. It was the exact same size. The dilations, it changes the size. Now, the same thing happens with dilations, though, in regards to its shape. Just like the other three, the shape is still the same. So the shape still has to stay the exact same shape, meaning each of those has those congruent angles that matches in a different shape. But the dilation will change in size. And we'll talk about how they're going to change in size in our next lesson. So when we talk about this first one, so the blue, does it come as a dilation from the red? Well, in this first one, I would definitely say that we have a dilation. We do have the size has gotten smaller, but the shape is still the same. So we're going to write as an explanation, smaller size, same shape. So it can't just be that it gets smaller on parts of it. The whole entire thing has to get smaller in the same way to keep that same shape. On the second one, when I look at these two, they have the same shape, but they're also the same size. So in this case, we would say, no, this is not a dilation. What I would say on this one, and again, I guess it kind of depends on a lot of things, but this kind of looks like a translation. So, but definitely it's not a dilation. So in a dilation, the value of the ratio of the side lengths of the image to the corresponding side lengths of the original is called the scale factor. And this is how we can determine side lengths as these get bigger or smaller. Scale factor. We use the letter K to represent that when we're talking about solving things, and we'll see some of that as we go forward. But the letter K means the scale factor. But it's how we determine how much bigger or smaller our sides are going to become. So here's a chart we talk about in the first couple where we're looking at what the words mean, the algebra, and the picture. So off to the left here, this is basically what in words we're going to do to how to dilate in this coordinate plane. So what we're going to do, we're going to multiply all of our x's and y's of all the ordered pairs by the scale factor to get our new ordered pairs or coordinates. And that's going to help us create this picture. Remember, the A, B, C without the primes means this is my original, to change into this A prime, B prime, C prime. Okay? So, the algebra look to this. k is our scale factor. So what we're going to do is we're going to take all of our ordered pairs, x comma y, and we're going to say multiply the x by k, also multiply the y by k, and that will create our new image points. So let's see how one works. So just like we've been saying on all of these, read the directions and understand what's happening before you go ahead and do this. So what we're going to do is we have the vertices of a triangle. We're given those vertices. A is 1 comma 3, B is 2 comma 3, and C is 2 comma 1. Draw the image after a dilation. So maybe make a note to yourself. This is a dilation, scale factor of a 3. And identify the type of dilation. Is this an enlargement or a reduction? Well, let's look at it. So if I have my A, B, and C, so we're just going to do the work to the side here. A, B, and C. We have 1, 3. We have 2, 3. And we have 2, 1. So with the scale factor, remember that would be my new image points, A prime, B prime, and C prime, is k times the x, k times the y. So A prime is going to be 1 times 3. B prime is going to be 3 times 3, which means A prime is going to be at 3, 9. B prime, we're going to take our x and multiply it by the k. We're going to take our y and multiply it by the k. So B prime will be sitting at 6 comma 9. C prime, 2 times the k, 1 times the k. C prime will be sitting at 6 comma 3. So now I'm just going to plot my points. So I'm going to pause the video, plot your triangle ABC, and also plot your triangle A prime, B prime, C prime. So if you did this correctly, you should have something like this, where you have ABC is that little smaller blue triangle, the green A prime, B prime, C prime is the larger triangle. So to answer the question, what type of dilation is this? Our picture has definitely gotten bigger. This is definitely going to be an enlargement. Which, if you think about it, makes sense. If I multiply anything by something greater than 1, and 3 was our scale factor, anything multiplying by greater than 1 should definitely be giving me something that shows an enlargement. The numbers got much bigger. We want to keep that in mind as we go forward. So next we have a rectangle. We're given these ordered pairs, and we have to determine what is the new dilation, again, with a scale factor of 0.5. Remember, 0.5 is really 1/2, so keep that in mind. And then we have to identify the type. So W, X, Y, Z. So we're going to take -4, -6. We're going to take -4, 8. We're going to do 4, 8. And we're going to do 4, -6. Now again, and I'm going to kind of skip the one step here to get to our primes. If you need to re-look at how we got these, if you're not understanding, you can certainly go back and re-watch example 1. But what we're going to do is we're going to multiply all of these coordinates, all of the x's and all the y's of all 4 of these points to get our new primes. So first, -4 times 1/2 is -2. -6 times 1/2 is -3. So that's going to now create W prime. So then I move to the next one. For x, -4 times 1/2 is -2. 8 times 1/2 is 4. Going on to y and y prime. 4 times 1/2 is 2. 8 times 1/2 is 4. And on to z. 4 times 1/2 is 2. -6 times 1/2 is -3. So just multiplying every single x and every single y gives me my new prime numbers, my new prime locations. So I'm going to pause the video, please graph those, and we'll see what we come up with for our picture. So here should be the picture that you have. W, X, Y, and Z is clearly much bigger as it's outlining the smaller shape on the inside. So what we would call this is a reduction. The blue figure has definitely gotten smaller. So again, like we just mentioned on the previous one, when you're multiplying by numbers greater than 1, it would make sense that those numbers get bigger. On the same end of this, when I'm multiplying by something between 0 and 1, so less than 1, the pictures will get smaller. So let's just make a little note here, so a little star. So when my scale factor is greater than 1, I'm going to get an enlargement. When it is less than 1, I get a reduction. So next we have one where we're using more than one transformation. We really have to be careful on these. So first I want to notice that we are doing the vertices of trapezoid. We can plot those points. Then we're going to dilate the trapezoid with a scale factor of 2. Then translate 6 units right and 2 units up. So we really have to be careful of how we do this. So we got to kind of combine what we know about 2 different transformations. So what I'm going to do is I'm going to write my initial ones first. So A, B, C, and D. So this will be the dilate. So notice that we are told to do this one first. So -2, -1, -1, 1, 0, 1, and 0, -1. So A prime, if I was to multiply by a 2, we would get -2 times 2 is -4, -1 times 2 is -2. B prime, -1 times 2 is -2, 1 times 2 is +2. C prime, 0 times 2 is 0, 1 times 2 is 2, 0 times 2 is still 0, and -1 times 2 is -2. So let's first, just so we don't lose what we're doing here, pause the video, plot the original trapezoid, and plot the dilated one, just so we can talk about that. So hopefully you have this picture. Now I will say I don't have the black original shape labeled correctly, but with my stylus it's not able to make it as clear and clean without making it too messy, so I didn't do it. But notice that the black trapezoid is my original shape. Then I have the A prime, B prime, C prime, D prime in blue as the new enlarged dilation. And again, please notice, same shape. It looks like the exact same trapezoid, but it is definitely bigger. So the shape has gotten bigger. So next, let's move on to the translate, because there was 2 parts. So it said to also translate. Now remember, 6 units to the right means we're going to add 6 to our x values. 2 units up means we would add 2 units to our y values. So now remember, we are not starting back with our originals. We are now starting with our prime coordinates. So -4, -2, -2, 2, 0, 2, 0, negative 2. And then also remember, we're not going to have a prime, it'll be a double prime. So if I add 6 to negative 4, I get 2. If I add 2 to negative 2, I get 0. For B prime, double prime, negative 2 plus 6 is 4. 2 plus 2 is also 4. C double prime, 0 plus 6 is 6. 2 plus 2 is 4. And D double prime, 0 plus 6 is 6. Negative 2 plus 2 is 0. Now I'm going to pause the video. Please plot those points, and we'll see if we have the same shape. And there is the picture: A double prime, B double prime, C double prime, D double prime. And again, please notice, with the translation, we kept the same shape, and it's the same size as the prime trapezoid. So the dilation enlarged it, but it then stayed that same and same shape when it went from the blue to the red shape. And then we have this real life problem we want to look at. We have a wildlife refuge mapped onto a coordinate plane where each represents a 1 mile distance. The refuge has these vertices. An expansion of the refuge can be represented by a dilation with a scale factor of 1.5. So there's the first time we're now seeing what we're going to be doing. We're going to be increasing to it's greater than 1 the refuge to see how much of this area does it increase. So a couple of things. So first, let's just focus on J, K, L. If I was just to take these original points and plot these, I would have a 0, 0 for J. I would have a 1, 3 for K, and a 4, 0 for L. So the refuge is that size on the map. Okay? Now, what we're first going to do is that dilation. So the dilation, which is going to make it J prime, K prime, L prime, 1.5 times each of these. So the first one, notice, stays the same. J prime is not getting any bigger. It's still going to be at 0, 0. When I go to K prime, 1.5 times 1 is 1.5. And 3 times 1.5 is 4.5. And that point will be about there. So that's where K prime was. J prime, again, they're a little too confusing right in here to put those originals, but notice the originals were the blues. And then I'm going to go 4 times 1.5, which is 6, and 0 times 1.5 is still 0. So then that I can plot at 6, 0. So notice the refuge has gotten bigger, which makes sense because they're multiplying by greater than 1. But this doesn't really answer the question on this. They're saying, how much did the area of this refuge increase? So remember, back in another grade, when I do the area of a triangle, the formula is 1/2 base times height. Now also remember that we have to have the height which is perpendicular to the base, meaning the height is not this diagonal thing going up or this diagonal thing coming down. The height would be the thing that comes straight down to create the 90-degree angle. So the height of the blue triangle is actually 3. The height of the red triangle would be at that 4.5 that would come straight down to create the 90-degree angle. So let's do it this way. So let me say this. So the old, which is the blue, the old one would be the area equals 1/2. The base would be between 0 and 4, right, across the bottom. And the height we just said was a 3. Now I can just multiply all that together. 1/2 times 4 times 3. Multiply all that, I get 12 times 1/2, which is 6 square miles. So then let's switch over to the new, after the dilation. So the area now is 1/2. This time it's from 0 all the way over to 6, and it's times 4.5 for our height. So this time, when I do my area, I would multiply all this together. 1/2 times 6 is 3, and then 3 times 14.5 is 13.5 square miles. And they're saying, how much does the area increase? So basically, I'm going to take the new and subtract the old to find out the increase. So 13.5 minus 6 is 7.5 square miles. So it wasn't just about doing the dilation, we had to figure out a little bit more to find the answer. So basically, as a quick overview so that we can be done, the dilation is one of our last transformations. This is the fourth one that we've looked at. Unlike the transformations that we've done before, this one's size does change. It either gets larger or smaller. The shape, though, still has to stay the same, so you have to be careful of that. So when you're working on your scale factors, you know it's an enlargement if it's greater than 1. If the scale factor is between 0 and 1, it would be a reduction. But the shape should still be the same even though it's getting bigger or smaller. So hopefully you can do pretty well with this. Please make sure you ask any kind of questions you have next time I see you.